Mechanics is a science concerned with the motion of bodies under the action of forces, including the special case in which a body remains at rest. Of first concern in the problem of motion are the forces that bodies exert on one another. This leads to the study of such topics as gravity, electricity, and magnetism, according to the nature of the forces involved. Given the forces, one can seek the manner in which bodies move under the action of forces. This is the subject matter of mechanics proper. Mechanics may be divided into three branches: statics, which deals with forces acting on a body at rest; kinematics, which describes the possible motions of a body or system of bodies; and kinetics, which attempts to explain or predict the motion that will occur in a given situation. The science of mechanics is a broad area, as can be demonstrated in the definition above. It dominates much of what will be covered in this course. As such, it is necessary to break down the chapters in our book devoted to it into several modules before extending on to other topics to be covered this semester. Module 1 contains chapters 1 through 4. Chapter 1 addresses those items expressed in one of the competencies of this course. Use systems of units and dimensions and convert between different systems of measurement and temperature scales. Temperature scales will be covered more in later chapters, but unit conversions are something that will be done throughout this text, and getting comfortable doing so begins with this chapter. One will also find demonstrations of such things as significant digits, scientific notation, and problem-solving techniques here, which will be very important when doing the problem-solving homework and completing problem-solving in quizzes and tests. Graphing is also covered here, important for those that are also taking the lab course associated with this class. Chapters 2 and 4 address several of the competencies of this course, including 1. Find the components of a vector and add them algebraically as well as graphically. 2. Apply Newton's laws of motion to analyze problems such as inclined planes, Atwood's machines, etc. And 3. Construct free body diagrams to identify the forces affecting the motion of an object such as friction, normal, weight, and tension. Newton's laws of motion are three fundamental laws of classical physics. The first states that a body continues in a state of rest or uniform motion in a straight line unless it is acted on by an external force. The second states that the rate of change of momentum of a body is proportional to the force acting to produce the change. The third states that if one body exerts a force on another, there is an equal and opposite force, or reaction, exerted by the second body on the first. These general expressions can be used to construct equations describing the interaction of forces on an object that may either lead to an equilibrium situation, in which an object is not moving or is moving at a constant velocity, or can lead to an object undergoing acceleration, which can mean it is speeding up, slowing down, or traveling along a curved path. Setting up these equations for both one- and two-dimensional motion will be applicable throughout this course as well as Physics 203, College Physics 2, for those that go on to take that course. Chapter 3 addresses the course competency Analyze one- and two-dimensional motion and interpret graphs and strobe diagrams. It introduces definitions of terms such as displacement, velocity, and acceleration, as well as equations that relate these terms, known as the kinematic equations. These equations, as well as Newton's laws, form a collective methodology of problem solving that goes well beyond these 4 chapters throughout this course and again on into Physics 203. In short, they begin the building of a toolbox, one that needs to be updated with each subsequent chapter and not left behind as if only useful in the chapter in which they are introduced. As we make our way through this course, one underlying theme that you should carry away from this course is the process of critical thinking and its applications to a variety of phenomena experienced every day. By looking at the world using objective analysis and evaluation, one can better form judgment not only about those phenomena covered in this course, but in the wide variety of experiences we have every day in our interactions with others. This course tries to demonstrate the applications of critical thinking skills to physics-related phenomena, but as a skill, it has much broader application once learned.